Okay guys, here we go again. So question 4, page 93 of Discover Graphics. Shown opposite is the logo for the design house Givenchy, and it uses axial symmetry to create an interesting pattern using the letter G. So this creates an icon that can be used both as a pattern in the product and products they design, and as a recognizable company logo. So using the dimensions provided, reproduce the logo. Use axial symmetry across the lines L and L1 and Q1. So we'll probably start with L to L1. Well, of course, we'll start by drawing the image. Lovely. Cube. Is it cube? No, it's not cube. 10, 10, 10, 10, 10. 5 of them. 10, 10, 10, 10. 4 of them. So, but it's all based on it's based on a grid. So let's get that drawn up first, and then let's position L, L1 and Q1, which is 5 millimeters away from the corner. Again, not ideal for swinging axial symmetry, but those are dimensions, so let's work with that. So it's going to go across LL1, it's going to end up here, and then the two images you'll have here will move down axially, mirror image below QQ1. So this image can be drawn in the top left-hand corner of your page, and all the movements will be to the right and downward. So nothing will be moving in that direction. So we can keep it up that far into the corner of the page. Loads of height there. Let's start there. Let's come across. Let's go up. And we're looking at 10, 10, 10, 10. And up the side. Now heavy in what we want, so across the top, fully heavy. Now how are you seeing that? Lovely, grand. Down 2, 3, down 3. In 2. Up 1. Back out 1. Up 1. Back out 2. Down 3. And all the way out to the edge. And then just frame in the rest. So do the base first and then do the 2 verticals. And hopefully at that point, the G, as they call it, should be standing out to you. And it does. Okay, so LL1 was 5 millimeters away. 5 millimeters. And look, QQ1 was down 5, so let's just mark it in. We won't use it now just for a minute. Let's just put it in there. So there's Q1. And then we'll do LL1 also. Yeah, the question asks us to copy the shape, the image in axial symmetry across LL1. And again, in this instance, LL1 is a vertical line, so all points need to move across it at 90 degrees. 90, 90, 90. All, including this one and this one and this one, all lines across it at 90 degrees. So we kind of had them there already. Likely across it, every single one of them creating a 90-degree gap or 90-degree angle to the axis. Now, at the minute, all of those come across. We don't know how far they're going. At the minute, we don't care how far they're going. That's going to be solved by the compass. So, whatever distance each point on the G moved to get as far as the axis, it moves across the exact same distance. So, whatever distance it is from here to here, it moves out here the same distance. Whatever distance it is from here to the axis, it moves out the same distance. So a good idea here is to label every point. There's quite a few here. 1, 2, 3, 4. I go around clockwise so that we know we've taken in every one. 5, 6, 7, 8, 9, 10, 11, and 12. 12 points, quite a few. And logic would dictate we'll start with number 1. So, point on the axis. The nib, the lead of the pencil, goes to number 1, and it goes across the axis, and it marks the new position of number 1, which we'll call 1, 1, double 1. 2. Now 2 is only 5 millimeters away. Very small on the compass, but there we go. That'll work. Very tight. If you couldn't measure it on the compass, measure it with your set square. And that becomes 2, 1. Number 3 is actually the same distance. And here's where you can cheat a little. 3 is the same distance. Number 10 is the same distance. Number 11 is the same distance. So if all of them are the same distance, try not to change your compass and mark them all in. 3, 1, 10, 1, 11, 1. 7 and 6 would be 10 millimeters plus the 5, 15 millimeters away. But again, we don't care what distance they are. We set it on the compass. Point to the compass on the axis, move back to number 7, then swing 7 across the axis, and this becomes a new 7. 7, number 1. And the same for 6. And that's all of those. 6, 1. 4 and 5. Point on the axis. Measure back as far as 4. Swing it across, there's the new 4. Point on the axis, swing it back to number 5, bring it across number 5. 5, number 1, 4, number 1. And we're left with 8, 9, and 12. So you fly through them. 12 points there done in, I'd say, 2 minutes tops. There's number 8. There's number 9. And number 12 is further away. So again, point on the axis, point of the compass on the axis, measure back to number 12. We should of course be in line with number 1. So this is the new 12, 1. This is number 9, 1. And this is number 8, 1. And that should be them all. All of these lines are vertical and horizontal, which is nice. Heavy them in. And you should get the mirror image. So we have our mirror image of the G. And now they want us to axially transfer all of that image. So all of this is going to transfer down below the page, down below QQ1. So it's going to move up there a little bit. And again, 90 degrees across the axis. The axis is now QQ1. So 90 degrees, QQ1 is horizontal, 90 degrees across horizontal is a vertical line. Every point. Do we care about the distance? No. So bring them all down. Now we had 12 points the last time. Now we're going to have double it, obviously, because we've doubled up the image already. So our 12 points have become 24. So we have a lot of work to do. These are construction lines, so they're light. I'm not pushing on the pencil much at all. Every single point from the axis, which is now QQ1, back up to number 1. Measure it down. Now, that number 1 also works for number 2 here. Let's mark it in. It also works for the number 2 here. So mark it in. And it works for number 1 here. So mark it in. And rename them all. 1, 3, 2, 3. And I would nearly go with 2, 4 here and 1, 4. But it's up to you at this point. I'd say it'd probably be okay to get it right. I'm going to move down a distance. We're on to number 8. Point to the compass on the axis. Measure as far as number 8. So this will become 8, number 4. That also works for 7. Mark it off. That also works for this other 7. The original 7. And it works for the original 8. And as we go, we mark them in. 8, 1. Sorry, 8, 3. 7, 3. 7, 4. 8, 4. 5 and 6 this time. From the axis, back up as far as number 5. Down the opposite side. Works for number 6 as well. Works for the original 6. Works for the original 5. Nine, 3. 10, 3. 10, 4. 9, 4. Now, the last ones, I'm going to say they're 5 millimeters. They're so small. I'm not going to measure them with the compass. I'm just going to measure, double check, 5 millimeters. So if here is 5, I'm going to measure down here 5. And I'm going to take a line along there. So it's on 12, it's on 11, it's on 11, and it's on 12. And all them are marked in. So we got 12, 3, 11, 3, 11, 4, and 12, 4. They're all our marks. Now it's simply a case of joining the dots. And my apologies for the light there, guys. I don't think that made much difference, but you'll be able to see it fine. So 4 goes to 2. No, so number 1 goes to 2. This one joins up to here. And the same on the bottom or the top, whichever you want to call it. It's the bottom mirror image. Joined up. Up here we got a full line. Here we don't have a full line, so it's going from number 2 to number 3. So there's 2 going to 3. So over here we've got 2 going to 3. So up here we've got number 3 goes to number 4. So there's 3 going to 4. 10 goes to 9. 10 does indeed go to 9. 11 goes to 10. 9 goes up to 8. 8 goes to 7. 7 goes to 6. 6 goes to 5. And 5 goes to 4. Is that our original image mirrored this way and then mirrored this way? So a double movement, a double axis, a nice bit more work. It'd take a little bit more time. Good luck.